Today's lecture is 7.5, Solving Radical Equations. In the last lecture, I mentioned that when you square a square root, the square and the square root cancel each other, that they are inverse functions. Let me show you that more specifically. This fact is found on page 629, and it says that for any non-negative number a, remember that we have to continue to include this disclaimer, that the number inside the square root will be a non-negative number, otherwise we would have to use absolute value signs. So going forward, we will continue to assume that the number represented by these variables inside the square root are non-negative numbers for the sake of being able to do this, all right? So if you have this expression where you're taking the square root of a variable or a number, and then you square the square root, the square and the square root cancel each other, they are inverse functions, resulting in what was underneath the radical all by itself. So we're going to use this fact today to solve radical equations. So let's look at the first two problems from the MyOpenMath homework assignment. Question number 1. This is a radical equation because we see the radical sign and we see the equal sign. That's how we know it's a radical equation. To undo a square root, you use the square. So in order to solve this equation, we will square both sides. Remember, with an equation, what you do to one side, you must also do to the other side. So if I square the left side, I must also square the right side. Show this work. When you square both sides of the equations, you need to show squaring both sides with your notation. The result is the square of the square root of 7y is 7y, and of course the square of 10 is 100. Then you finish this problem by dividing both sides by 7. To check your answer, plug 100 divided by 7 back in for y, and you'll see that you end up with a true statement. Look at question number 2. Before you square both sides, make an observation. The square root equal to a negative number? That's not possible. The output of a square root is always a non-negative number. So at this point, you can already conclude there is no solution. But suppose you hadn't noticed that there is no solution when you first start. If you square both sides, the result is x equals 81. Now plug that back in. So you can see how to check your work. Either way, you need to conclude that there is no solution. So here I have put up question 3 and question 4 from the MyOpen Math assignment. The first step is to make sure the square root is isolated. Make sure it's already all by itself, which in question 3 it is. In question 4 it is not. So when we get there, we'll have to add 6 to both sides. For question 3, we start by squaring both sides. Continue this problem and see if you can also do question 4. So pause the video now and try both questions. Okay, for question number 3, you show squaring both sides, the result, then we add 4 to both sides, and our final answer is t equals 85. For question number 4, before we square both sides, we must get the radical all by itself. We must isolate the square root. We do that by adding 6 to both sides. When you add 6 to the left-hand side, the result is simply the radical. When you add 6 to the right-hand side, of course, 4 plus 6 is equal to 10. Now square both sides. And of course, you can check your answer by plugging your answer back into the original equation. 117 minus 17 is 100. The square root of 100 is 10. 10 minus 6 is equal to 4. Now let's try the next two problems. Go ahead and pause the video again and try each of these two problems on your own. And then once you've tried your best and you've done as much as you can, continue the video and you'll see the worked out solutions. Okay, I didn't finish question 6 yet. I will get to that one soon. Let's start with question 5. First, subtract 2 from both sides. Once you get the radical all by itself, once the square root is isolated, then you can make the observation that the square root equal to a negative number is impossible. That's when you write no solution. So don't write no solution immediately. First, show the work of getting the square root all by itself. So for question 6, I first need to get the square root all by itself. So first, subtract 7 from both sides. 4 minus 7 is negative 3. Then I have a negative 4 outside the square root. This is multiplication. So we need to divide both sides by negative 4. When you divide the left-hand side by negative 4, this is the result. When you divide the right-hand side by negative 4, negative 3 divided by negative 4 is positive 3/4. This square root is equal to a positive number. That's okay. So now we continue by squaring both sides. To subtract 3 from both sides, you do need a common denominator. So I'm going to show 3 as an equivalent fraction on the right-hand side. So on the left-hand side, I subtract 3, but 3 is the same thing as 48 divided by 16. Nine minus 48 is negative 39. So the answer is x equals negative 39 over 16. If I want to check my answer, I plug it back in. Negative 39 over 16 plus 48 over 16, that is 3, is a positive 9 over 16. Square root of 9 over 16 is 3/4. 3/4 times negative 4 is 3. Negative 3 plus 7 is 4. If that was too much for you to do mentally, that's okay. You can type that all into the calculator. Let me show you how. Okay, so let me put this right up here. Aha. Can you see that clearly? Negative 4 times the square root of negative 39 over 16 plus 3 equals negative 3. So what did I do wrong? I forgot to include plus 7. So let me try that again. In order to include plus 7, you do have to arrow to the right to get out from underneath the square root. Okay? This is like moving in front of a mirror. When I try to move right, it goes left and vice versa. Okay, I think that should be clear. So make sure that the square root covers only what is inside the square root, and what is outside the square root is clearly outside the square root. Your notation when you write should be as clear as the notation in the book and the notation on the calculator. I'm still trying to make a decision about how we're going to handle test 3, but in the meantime, you need to practice in your homework in the same way that you would be completing answers on the test, right? Just as in sports, you practice in sports the same way you will perform. So practice for the sake of performance, and that will be your best bet for success. Okay. So now let us look at question 7 and question 9 from MyOpenMath. These will be different because unlike the previous problems, which resulted in a linear equation to solve, these will result in quadratic equations. Let's start with the one on the left. Question 7. The radical is already isolated, so we can immediately square both sides. The resulting equation is a quadratic equation. Remember that when you have a quadratic equation, you need to use the zero factor property to solve it. So what that means is you need to get everything on one side and 0 on the other. Since you will need to factor make sure that your leading coefficient is positive. So the number in front of x squared needs to be a positive number. That's why I chose to move everything to the right side. Now I factor. Then use the zero factor property. Now remember, it is possible to do the problem correctly and still end up with an answer that's a bad apple. Those kind of solutions are called extraneous solutions. So always check your answers. If you plug in -5, you'll end up with a false statement. I can tell that without even plugging it into the left-hand side. A -5 cannot possibly be the output on the right-hand side. Look. Regardless of what the left-hand side simplifies to, the right-hand side cannot equal a negative number. The square root of a number cannot be negative. Not if it's the principal square root. Remember that the principal square root is always a positive square root. So the output should be positive. That does not mean that you reject every possible negative solution. It just depends on what the original problem looks like. So always check every solution, each one individually. For each individual problem, treat each problem separately. You must always check your answers. Okay, so now let me check 7. Plus 35 is 49. The square root of 49 is equal to 7. So 7 is a good answer, and -5 is an extraneous solution. Never cross out your work, ever. Crossing out your work is what you do when you do not want me to read it. That's what you do on a test when you've tried a problem and you know you've done it the wrong way, so you cross it all out and start again. So never cross out your work if you want me to read it. Instead, for your final solution, simply include only solutions that are good solutions. Do not include extraneous solutions in your final solution. Question number 9. Pause the video now and try that one on your own. Okay, so start by adding 1 to both sides. Now we have the square root all by itself, so we can square both sides. Show squaring both sides. Remember that when you square a binomial, you get a trinomial. The product is not x squared plus 1, but x squared plus 2x plus 1. Now I see that I have a quadratic equation. So that means I want everything on one side and 0 on the other side. At this point, you should always get something that factors, because if you don't, you can only solve it using the quadratic formula or completing the square. And we're not doing that yet. That comes in the next chapter. So when you get to this point, If your quadratic equation does not factor, go back and check your work. So next I must check my answers. If I plug in a -3, I'll end up with 2 minus 1 is equal to -3, and that won't work. If I plug in a 4, I'll have 5 minus 1 is equal to 4, so 4 is the answer. Both of these had an extraneous solution. Sometimes you won't have an extraneous solution, and that's okay. Don't expect that you must always have an extraneous solution. Sometimes you do, sometimes you don't. You'll notice that when you look at the textbook, we do not cover the entirety of 7.5 in this class. There are some topics in 7.5 that I've left out because they are not required by UAA as part of the course. So that's a good thing. It makes 7.5 easier. I do want to end this lecture with a word problem. So I will do number 106 on page 638. I highly encourage you to follow along in the textbook. The taller a lookout tower, the farther an observer can see. The distance d, called the horizon distance, measured in miles, is related to the height h of the observer measured in feet by the formula d is equal to 1.22 square root of h. The problem begins by defining variables. D is the horizon distance measured in miles. H is the height of the observer, which of course depends on the height of the lookout tower. This height is measured in feet. The formula given is d equals 1.22 square root of h. Now, the problem says, how tall must a lookout tower be? Remember that the height of the observer depends on the height of the lookout tower. So what is unknown is how tall that lookout tower must be. In other words, h will be unknown in this problem. So h is what we're solving for. Continue. How tall must a lookout tower be to see the edge of the forest 25 miles away? 25 miles away, that's horizon distance. So we replace d with 25, not h. First, begin by dividing both sides by 1.22. The resulting fraction I will leave as is, 25 divided by 1.22. Of course, this is not a simplified fraction, but that's okay. I don't need it to be simplified yet. This number is still equal to a square root. So next, I square both sides. It's at this point that I'll type 25 divided by 1.22 squared into the calculator. Make sure you use parentheses so that you don't only square 25 or 1.22. You need to square the entire fraction. And the problem says to round to the nearest foot. 420. That means that the height must be about 420 feet. The lookout tower must be 420 feet tall in order for the observer to see 25 miles away to the edge of the forest. That ends our lecture for 7.5. This lecture we only cover one lesson, so instead of 2 separate YouTube videos for today's lecture, you only need to watch one video, so that's exciting. If you have any questions, please email me. Make sure that you are following along with the new syllabus. Pay attention also to the options that you have for written homework. You can either email me the entire required set, or you can post a question and give me an email diary of your work, or you can reply to a question and give me an email diary of your work. All of this is explained in detail in the revised syllabus. I will see you next lecture.